Okay, so let's see what happens if the terminal arm moves to quadrant 2. So this angle right here is range between 90 degrees to 180 degrees. So because the quadrant 2, so that's why we got this range. It doesn't pass 180 degrees and it should be greater than 90 degrees, right? So the radius is at this point, angle stops rotating from this point, and we got the point here, negative x and y. So negative x and y tells me that the horizontal distance from this point to this point is negative x. So y tells me that the endpoint here to this direction is y unit, right? So the vertical distance is y unit, horizontal distance is negative x unit. So this is the right triangle we're using to calculate the trig ratio in the right-hand side. Okay, so let's figure out the trig ratio for this right triangle. So let's first compute sine theta. Sine theta, we have opposite, so which is y, divided by the radius, right? So we have y over r. So what about cosine theta? So cosine theta is x, right, adjacent divided by r. So but be careful because every x value in quadrant 2 is negative. So that's why I need to put the negative sign here, and it tells me that the x is negative, right? So what about the sign for the radius? So the sign for radius always remain positive because the distance from origin to the end point. So I know that radius always positive. So we have negative divided by positive, and we got the negative cosine theta when the angle theta is between 90 to 180 degrees. Okay, so that's why we got negative cosine value for quadrant 2 angle. So what about tangent theta? So tangent theta by definition is y over x. We have positive y and negative x, right? So that's why this ratio is also a negative ratio because we have negative x in the bottom and positive y in the top. So this is the reason why you got the negative ratio for cosine theta in tangent theta, but not for sine theta because both y and r are positive in quadrant 2. So also you need to keep in mind that the angle here is a standard position angle. It's the black angle right here. It's the angle between 90 degrees to 180 degrees, but not the green angle right here. So reference angle is a really important concept because it helps you actually solve the trig ratios, which is greater than 90 degrees. So which is great because we have this right triangle here. And also the reference angle is the angle between the terminal arm and the closest x-axis. So you need to keep in mind that, and we'll be discussing reference angle later in this video.